Hello everybody. As per the time announced from Uma's classroom, I'm starting my live session on the topic integers. So, welcome to Uma's classroom. Hope all of you are doing well. This topic is good for 6th graders to 9th graders, but it does not mean that the learners who does not belong to this category, they are not allowed to join. Anyone from anywhere can of course join. Please maximize your screen and adjust the volume of your device to the highest level for a better quality. And by nature, I am not a very fast speaker, but due to some technical issues or maybe the difference in internet speed, sometimes there can be a voice drop. No worries about that. The moment the session will end, in few minutes the session will be available in Uma's classroom as a video. So whoever is missing any part of the session would always welcome to watch that as long as you want, as much as you want. And let's see how it works. If you have any question, please type it in your chat box. Time to time, I will definitely go through them. And if it's seen that right now it is not answered, of course, I will get back to you after the session. So let's start our discussion for today's topic, integers. I hope you all can see the writing on this white board. So the topic is integers. We would like to start our discussion from the definition of integers. And maybe many of you already know integers are the whole numbers anywhere in between 0 to positive infinity to negative infinity. So, according to mathematics, set means actually a group of separate objects. So if I consider the numbers are group of separate objects, so integers can make a set like this. I'm writing over here. -3, -2, -1, 0, 1, 2, 3, and then again it ends up with 3 dots. Actually, these 3 dots at the beginning and at the end, it is referring to its limit as positive infinity to negative infinity. Now, let's see how can we represent integers on a number line. If we want to draw a number line, it would look like this. Suppose this is 0. We all know that 0 does not have any positive or negative value. Yeah, I can see the message here. Hi, Aritra, welcome to the session. Yeah, good. Let's start our discussion. And first we will discuss something, then we will do some problems. Then maybe I am also giving you to do some problems. Just make sure your volume is adjusted to the highest level and your screen is maximized. So we are coming back to this, how to represent the integers on a number line. So this is my number line, and hopefully you can see this end and this end of the number line. There are 2 arrows Yeah, hi Nilotpal. Welcome to the session. Hope you all enjoy. Thank you for being here. These two arrows are actually indicating the limits. It is this side, it is indicating positive infinity, and this side arrow is indicating negative infinity. Now I'm going to represent few numbers on this number line. So when from zero, starting from zero, when I'm moving towards my right, or always it is indicating positive integers. So this is plus 1, this is plus 2, this is plus 3, and I hope all the children are sitting with pen and paper. So I want you to do the same operation or make a note, whatever we are talking over here, as you can use your note after the session whenever you want to use it. And I'm extremely sorry, I can clearly see that this line is not a straight line. As I'm drawing from here, it happens over there. That's the reason it's happening. And when you are drawing on your pen and paper, make sure you are using a ruler. Then you will get a good straight line. And so this is the positive values, this right hand side, and this is the negative value, negative integers, -1, -2, -3, and so on. Using this number line, we can perform different integer operations like addition, subtraction, etc. I'm showing you two examples. How can you perform integer operations like addition, subtraction? Suppose I am going to add +2 with +3. This is a very easy one. So first let's mark on the number line where is +2 and where is +3, or how should we proceed? I'm showing you. This is +2, my first number, and I can clearly see from the number line, this is the position of +2. And I can see my operation is addition. So when you are performing an addition operation using a number line, you have to move towards your right as per the basic rule of representation of integers on a number line. So I would like to move 3 steps forward towards my right. My next integer is +3. So I am starting to move towards my right. 1, 2, 3. This is the position I am reaching now after doing +3. Now let me count what is the value of this position. This is 0 and this is my right side. So definitely I am moving towards right. That means it representing positive integers. 1, 2, 3. This is +4. This is +5. And of course, the result of this addition is also +5. And I think many of you already know how to perform these operations. Just let's take another example of subtraction. Subtraction, when you are performing the subtraction using the number line, you have to move towards your left. If I'm taking an example, suppose -1, then -2. So first let me represent this integer. This is -1. So this is the position of -1. Then again negative, that means I would be moving towards my left. So if I'm moving towards my left, I can see how many steps I have to move? 2 times. So 1, 2. Definitely, when I am moving towards my left, this is the position where I can reach. And now if I count what is the value of this position, it is, yeah, I'm trying. I can see someone is not, cannot see the board. I'm trying to make it do that. And here I would like to mention another point. Whenever you are having two negative signs over here, it is going to be positive. So generally when we are performing the operation, what are we doing? -1 and two negative signs together means it is giving me a +2. So the final result is going to be +2. So it is working like that. The next thing we are going to talk about is additive inverse. Additive inverse is a very common term in integers, and I'm just showing two examples. It's easy to understand with the examples. Suppose my integer is +10, and the additive inverse of +10 is going to be -10. Suppose my integer is -8080. The additive inverse is going to be +80. So now I'm speaking about few general rules of integers. After this discussion, I will take few examples and we can do the sums together. Let me talk about a property of integers. Actually, for addition, subtraction, multiplication, and division, all the properties are known as closure properties. In mathematics, closure property means when an operation on members of any set is performed and it is clearly seen that the result of whatever we are getting after the operation is again belonging to the same set, then we can call that the set is showing the closure property. So for integers, if you add two integers, you will be getting another integer. If you subtract, definitely you will be getting another integer. Whenever you multiply, though still now we did not take any example of multiplication or division, but I will come to the point. We can do few examples together, of course. But whatever we are performing, after getting the result, we will see that our result is always belonging to the set of integers. So that's why all the properties are known as closure properties. And hopefully you have seen I am also using some papers and everything, whatever I need. So I always suggest the children to use the pen and paper whenever possible, do the sums, and as much as you can, please practice them well and make note. Even if it is not possible for making the note exactly right now, I'm repeating, after the session you will get the video available in Uma's classroom and make the note from there too. And next I am coming to the properties of addition of integers. Actually, addition of integer, it is commutative property. Commutative property means, suppose I am performing this operation and this will give me exactly the same result if the integers are just interchanging their positions. So from my left hand side it is 10, from my right hand side it is also 10. This is called commutative property, and this is true for multiplication of integers also. Let's take one example. Suppose 8 times 4 and 4 times 8. Always it is giving me the same value. And I can see someone is talking about the board. Maybe he or she cannot see the board very clearly. Maybe because of light reflection or something is happening. I'm extremely sorry for that. That's why I'm trying to narrate whatever I am writing, as you can make a note of it. And there is another important property of integers that's also true for addition as well as for multiplication. That is called associative property. Associative property is also very easy to understand. Suppose I'm writing an operation. Yes, hello Ananya, please welcome to Uma's classroom. Enjoy the session. 2 plus 3 plus 5 equals, so here 3 plus 5 is inside the parenthesis. That means they are grouped already. If I change the grouping and if I do this, then also I will be getting the same value. When this part is grouped inside the parenthesis, according to the rule of mathematics, it's going to be 3 plus 5, 8, plus 2, 10. And this 10 is my left hand side value. Let's check the right hand side value. 2 plus 3 is 5, plus 5. This is also going to be 10. So associative property means you can just change your grouping, keeping the integer values same. And this is true for multiplication also. And integer 0 and integer positive 1, they have a special property. Actually, integer 0 is known as the additive identity. Additive identity means if you add 0 to any integer, if someone can confirm, am I audible enough? To any integer, suppose with 7, I am adding this. With 7, if I am adding 0, I am getting back the same value. That means whenever you are adding 0 to any integer, you are getting back the same integer value. That's why this is called additive integer. 0 is called additive integer. With integer 1, if you perform the same operation, if you try to do the same but for multiplication. For example, 5 times 1 gives me back 5. 6 times 1 giving us back 6. It works like that. So when you are multiplying any integer, maybe positive, maybe negative, whatever it is, any integer with 1, you are getting back the integer value. That's why 1 is known as multiplicative integer. 0 is known as additive integer, as whenever you are adding 0 to any integer, you are getting the same integer back. and one is known as multiplicative integer. Yeah, thank you, Ananya, for confirming. And you can inform your friends or your relatives if anyone can enjoy the session now, afterwards. So always welcome. And I already mentioned for multiplication also, commutative property and associative property both are valid. We can check with just one example. So my left hand side is 6 times 7. This is giving me 42. The next is what I mentioned, it is commutative property. That means these integers, they are interchanging their positions. So 7 times 6 is also giving me a value of 42. This is called commutative property. So it is checked. Now I am going to check the associative property for multiplication. This is my example. 3 times 4 times 2. The value is, as this part is inside the parenthesis, so I will perform this operation first. 3 times 8. This is giving me 24. Now, just I am making a new group using the same integers. 3 times 4 times 2. As this part is inside the parenthesis, I would like to do this operation first. So 12 times 2 is again 24. So the values are same. This is called associative property. Multiplication has another property known as distributive property. And distributive property actually makes the multiplication easier. Thank you everyone who all are watching and of course confirming my question that I am audible to each and every one of you. Thank you so much. Please enjoy the session. So now I'm coming back to distributive property of multiplication of integers. Suppose I have the example like that. Here I have 5 multiplied with, inside the parenthesis I have 3 plus 2. That means this 5 will be multiplied with this 3 and then it will get multiplied with 2. If I perform this operation, 5 first it is 5 times 3, then plus 5 times 2. So this is 15 plus 10, this is 25. And if I check the value from here, 3 plus 2 is 5, 5 times 5 is 25. Actually, this distributive property makes the multiplication easier. If I take one example, suppose 63 times 12. So here, if I split this number 12 as 63 times 10 plus 2. So I will apply the same distributive property. 63 times 10, 63 times 10 plus 63 times 2. And we all know that 63 times 10 it's coming as 630 plus 63 times 2, it's a simple multiplication even for the junior level students also. So it is coming 126. Now I can add these two and get my result. 6, 5, 7. This is my result. And for multiplication and division, I'm coming to another point. Suppose I'm multiplying even number of negative integers. I'm multiplying, for example, negative 2 times negative 2. So 2 times I'm multiplying. When I'm multiplying even number of negative integers, the result is going to be positive. When I'm performing or anyone is performing the multiplication for odd number for negative integers like negative 1 times negative 1 times negative 1. 3 times I'm multiplying negative 1. The result is going to be negative 1. These, whenever negative 1 is multiplied for twice, it is giving me back 1. And again, 1 is a positive integer multiplied with another negative integer, we are getting back negative 1. So when negative integers are multiplied for odd number of times, you are getting negative result and results in negative integers. And when you are performing for even number of times with negative integers, you are getting positive integer as a result. So these are the few general rules we are using while solving the integer problems. Now I have few problems for you to solve and give me the result in through the chat box. And as I am getting a feedback that everyone cannot see the board very clearly, so definitely I am trying to narrate the problem as much as I can. Please bear with me. So are you all ready for the first problem? First problem is Mr. X is standing in the middle of a bridge which is 20 meter above the water level. Mr. X standing in the middle of a bridge which is 20 meter above the water level of a river. If a 35-meter deep river is flowing under the bridge, then the vertical distance between the foot of Mr. X and the bottom level of the river. Vertical distance between the foot of Mr. X and the bottom level of the river can be dash. Please try that and give me your answer. Vertical distance. So it is going to be like this. Suppose this is the bridge B and Mr. X is on the bridge. Now, how would you calculate? Yes, any one of you? Yes, anyone? Yes, Aritra. Okay, let's solve it like that. So this is my bridge. Suppose this is the water level, W. And according to the question, from the water level, as Mr. X is on top of the bridge, this distance is going to be 20 meter. This distance is going to be 20 meter. And then the question is saying the if a 35-meter deep river is flowing under the bridge, that means the river is 35 meter. And you have to find out the distance between the foot of Mr. X. Obviously, the foot of Mr. X would be here and the deep of the river, bottom level of the river. So the operation is simple addition. 35 plus 20, unit is meter. In handling story sums, take care of its units. So it is going to be 55 meter. This is my answer. Are you all getting the same answer? I am not getting anything over here yet. Okay, whenever you are done, you can post your answer over here. The next problem, I'm writing few integers and asking for the result after simplification. Negative 10 inside the parenthesis times positive 9. Close the square bracket, then plus negative 10. What is the value of this one? Negative 10 times positive 9 plus negative 10. Yes, you can try this one right now. I have just one guideline as this part is inside the parenthesis. So first perform this operation according to the rule. Here one is the negative integer, another one is the positive integer. So we have to perform this operation first. Negative 10 times positive 9, it is going to be negative 90. And here I have to add negative 10 with this quantity. Here again a positive sign and a negative sign. So definitely this is also going to be negative 10 according to the general rule of integer operations. If you have two same signs, maybe both the signs are positive, both the signs are negative, then you will always have a positive sign back. And when you have the different signs, negative, positive, or positive, negative, whatever it is, you have to end up with negative sign. As here I can clearly see the first one is positive and second one is negative. So as a result, I am getting a negative sign over here. And here the addition of two negative integers, negative 90 with negative 10, my result is going to be negative 100. Are you all getting the same value? Please check them when possible. And for integer addition subtraction, I would like to mention one general rule. If the sign of the integers are different, if the sign of the integers are different, then always you are performing the subtraction operation. So first compare with the absolute values. Absolute values means the values without any sign. So positive 2 will have the absolute value of 2 and negative 3 will have the absolute value of 3 only. So let's perform the operation what I mentioned already, subtraction. So 3 minus 2, bigger number minus smaller number, it's giving me 1. And the sign will be which is associated or linked with the larger number. As larger number is 3 and the sign linked attached to this larger number is negative. So my result will also be negative. This is one point I suddenly remembered that I did not mention while discussing addition subtraction. Keep this in mind. Now I'm moving to my next example. Next example is negative 16 divided by 8 divided by negative 2. Negative 16 divided by, inside the square bracket, 8 divided by negative 2. Close the square bracket. What is the value of this simplification? Simplify this. What is the value of this one? Is anyone performing? Then please type your answer in the comment box. Negative 16, keep it as it is. Let's perform this operation first as it is inside the square bracket. So 8 divided by negative 2. As one of the integer is positive and another one is negative, according to the rule of division, the result is going to be negative 4. If any one of the integers is negative and you are performing division operation, the result is always going to be negative. So, negative 16 divided by -4. Now look at these two integers, both of them are having same sign. So your answer is going to be +4. Any question for me? Next type of question, suppose a group of integers are given to you and you have to find out the odd one out. Please note down the group of integers. The first group is -2 and +24. -2, +24. Second group of integers, -3 and +10. -3, +10. Third group of integers, -4 and 12. -4 and 12. And there is another group of integers whose members are -6 and 8. -6 and 8. Now the question, how to find out the odd one out from this group of integers? It depends on the integers given to us. From this set of integers, I can clearly make a decision. If I multiply the members of each group, maybe for 3 of them, I'm going to get the same result. Whereas for the fourth one, I may not get the same result. So definitely, based on this operation, I can conclude the set of integers for whom I am not getting the same result with other 3 is definitely the odd one. So can you try that one for me and give me the result which one is not the which one is odd one, I mean. So as per my guideline, please multiply -2 with 24. You will get -48. Then the second set, -3 with +10. You will get -30, 30. For the third set, it is -4 multiply with 12. That is again -48. And the last set of integers, that is -6 multiply with +8, means again -48. So for 3 sets of them, I am getting -48, leaving the set of -3 and +10, which is on multiplication giving me a value as -30. So this is the odd one for this set. Are you trying them with me? Okay, I'm not getting any result over here yet. Okay, even if you feel that afterwards you would be posting the results, that's also fine, absolutely fine. And whatever questions you will be having, always feel free to reach out to me for those questions through Uma's Classroom. I have another odd one out type question. Please note down the numbers. The first set of integer is -3 and -6. -3 and -6. Second set of integer is +1 and -10. +1 and -10. Third set of integer is -2 and -7. -2 and -7. And the last set of integer is -4 and -9. -4 and -9. Please try them. I'm giving you the clue in a moment. Okay, someone is waiting for the session. Let me reply to that. Yes, any idea? How are you trying? For the last one, I had given you the clue to perform the multiplication operation. This one you can try using addition operation. So for first set of integers -3 and -6, if you add them together, you are going to get -9. Second set of integers +1 and -10, you are going to get a value of again -9. Third set of integers -2 and -7, you are getting a value of again -9. And fourth set of integer -4 and -9. If you add them, this time you are not getting -9, it is -13. So that means the fourth group of integers, fourth set of integers, this is the odd one in this group. Any question? Yeah, I cannot see any question over here. Let me move on to my next example. Yes, this question is of completion of patterns. I'm giving you few integers. You have to write the next 3 consecutive numbers. So the numbers are already there. It is 11, 8, 5, 2. These numbers are already there and all these numbers are positive integers. You have to write down next 3 consecutive numbers. So if you look into this pattern, the difference between the numbers are 3. So definitely the next number from here would be after skipping 3. So the next 3 consecutive numbers are going to be, I'm writing the answers in a different color. It is going to be -1, then again skip -4, and the last one is going to be -7. So this is the complete pattern. I am giving another pattern that you can try to solve. You can get the answer in your free time. The pattern is having the numbers -62, -37, and -12. -62, -37, and -12. -62, -37, and then -12. You have to write down the next number in this pattern. Get the difference of these two integers and then find out the next number. And it is, next number is going to be +13. Next number is going to be +13. I'm moving to my next question. I am giving you some values in terms of A. You need to find out which one is not the additive inverse of A. Which one is not the additive inverse of A. So the expression for option 1 is negative of -A. Option 2 is A times -1. Option 3, -A. And option 4 is A divided by -1. The question is, out of these 4 choices, which one is not the additive inverse of A? I hope you can solve this, simplify all these expressions, and for these 3 you are going to get the final value as -A, but for this one, the first expression, you are going to get the value as +A. So definitely this is your answer. Option 1 is not the additive inverse of A. Additive inverse of A means it has to be -A. Now I'm giving you 4 different ranges of temperatures, that is indicating the rise in temperature. You need to find out which of those values are showing the maximum rise in temperature. maximum rise in temperature. Option A, 23 to 32 . Next one is option B, -10 to 1 . Option C is -18 to -11 . Centigrade, Fahrenheit doesn't matter over here. You are going to get the difference only. And the option D, last one is -5 to 5 . So get the difference for all the temperature ranges and find out which one is bigger. The correct one is going to be option B. If you do the operation, if you perform this subtraction operation, and you will come to the conclusion, this is your correct answer. And in the next part, I'm giving you few problems that you can try in your free time. And of course, I would appreciate if you post the answer of those problems under the video whenever possible. And if you need the answers, please let me know. Definitely, I can disclose them. So please be ready with your pen and paper to note down one or two problems that you can solve in your free time. One moment. And I repeat, though it is mentioned that the session is good for 6th graders to 9th graders, but it is not like that the students following beyond of these class range in either way are not allowed to take the advantage of the session. Of course, you can do that, or anytime you can check and you can post your answers, you can ask me the questions. Just allow some time for me to respond back. One moment, I'm just scrolling down to get the question for you. Please be ready with your pen and paper by the time. And as I'm getting the feedback, I'm audible enough. So I'm going to narrate the question. Please make important notes, or you can write the question. It's up to you. The question is saying, in a table, it shows the lowest recorded temperatures for each continent. Write the continents in order from lowest recorded temperature to the highest recorded temperature. So, you will be provided with some values, and continent-wise, you have to arrange those integer values from lowest to highest. The first, you can make a list of it, or simply you can make a note. Africa, for Africa, the value is given as -11 °F. All the temperature values will be given in Fahrenheit. For Africa, it is -11 or -11 °F. For Antarctica, it is -129 °F. For Asia, it is -90 °F. For Australia, it is -9 degrees Fahrenheit. For Europe, it is -67 degrees. For North America, it is -81 degrees. And for South America, it is -27 degrees. So these are the values, and we can clearly see all the values are in negative integers. You have to write in order from lowest recorded temperature to the highest recorded temperature. So please write them down and post your answer over here, and please make it under the video. And if you have any question, that also you can post. If you have any request, that you can email me. You will get my email that is linked with Uma's classroom. And I have one last question for all of you. And this question, I'm going to give you one very common formula. You have to convert the integer values, and then you have to come to a conclusion. As this session is from 6th grader to 9th grader, so I believe the students from 8th grader, they all know this formula. It's a very common formula used in our science, especially in heat chapter. Just let me come to that one moment. Yes. Here again, I will be providing you some information. You can make a table or you can make a note of it that shows the freezing points in degree Fahrenheit of different gases at sea level. Now, convert each of these Fahrenheits into centigrades to the nearest integral value, and using the relation as C/5 equals F minus 32/9. This is a very popular and common formula from heat chapter. So though you know this formula, still I am writing the formula over here. Sorry. C/5 equals F minus 32 divided by 9. Or you may get this formula in a different form, but it means the same. C equals 5/9 times F minus 32. And now I will be giving you the values in Fahrenheit. So substitute that values over here and then get the values in centigrade. And let's see what's the question after that. So convert each of the Fahrenheit temperatures I'm going to give you into centigrade to the nearest integral value using this relation, and find out the temperatures of those gases at sea level in degrees centigrade. Please note down the temperatures in degree Fahrenheit. For hydrogen, it is -435 degree F. For krypton, it is -251 degree Fahrenheit. For oxygen, it is -369 degree Fahrenheit. For helium, it is -458 degree Fahrenheit. And for argon, it is -309 degree Fahrenheit. So just convert this Fahrenheit into centigrade. That is the question. And I already mentioned how can you solve this problem. So this is all about from my end. The session was more or less 1 hour long. And please don't forget to send me a feedback and let me know how can I improve the session. Hope you have enjoyed. Always discuss your topic with your friends whenever possible, even can be over phone. And if you are feeling that we can meet over here in this platform, please send me the topic you want to see. Hope all of you will be staying well. Be safe. Bye.